Hello friends, so today we are going to start with a new subject which is power electronics. So students, power electronics is basically a mixture of the fundamentals of two courses. One is power engineering and second one is electronics engineering. So it requires a prerequisites of some fundamentals of basic electronics that you have studied in your ECC subject and also some power system engineering. As and when it will be required, we will try to understand the basics so that we can able to grasp the concepts of power electronics easily. So let us start with our first lecture, Introduction to Power Electronics. These are the contents. The first one is introduction. We will start with the introduction. Then the need of power electronics. Why we need power electronics? There are certain industrial applications and residential application because of which we would like to study the power electronics. So it is useful subject. So we are going to study that. Then we will see the basic block diagram so that we can understand what are the different blocks of the power electronics. Then the application, there are many applications, some of them that we are going to see, and advantages and disadvantages obviously. Now before starting this lecture, first of all let us try to understand the role of power electronics through this particular video.
Electricity, our most valuable form of energy. No other energy form can be so efficiently and cleanly converted into all other forms of energy for our daily requirements of light, motion, or heat. However, electrical energy has to be transformed again and again on its way from the power plant, the photovoltaic solar module, or the wind turbine to the electrical consumers. This is done with modern power electronics. For example, a photovoltaic solar module produces a DC voltage which has to be...
So the first application is photovoltaic. As we know that it gives us DC, but we require a AC at our home and for all industrial purpose. So inverter is required. So in between we are having a power electronic device which is called as an inverter, which convert DC from AC.
Be converted into the standard 230 volt 50 Hz alternating mains voltage using a solar inverter. On the other hand, your laptop computer requires a DC voltage.
Similarly, rectifier is also needed in our laptops for our chargers. So all the AC can be converted into DC using this rectifier
of a few volts that's rectified and converted from the mains voltage. In many applications, the frequency of an AC voltage.
Similarly, whenever we are using the renewable energy sources, at that time the speed of or the velocity of that wind turbine is not going to remain same. It's a variable frequency. So we need to convert into a steady frequency so that it can be given to a grid. So we required a in-between converter which is called as a frequency converter or a cycloconverter.
Has to be modified, such as when the electrical power from a wind turbine has to be fed into the grid with a constant frequency of 50 Hz despite fluctuating wind conditions. Another example is the frequency converter enabling the speed variation of an electrical motor as required. The role of power electronics is therefore to convert electrical energy as efficiently as possible into the necessary form and to control the flow of power. This is done by means of power semiconductors based on silicon, just like in microelectronics. Power electronics is therefore not restricted to gigawatts and megawatts, but can also be responsible for supplying a mobile phone or heart pacemaker with energy.
So it does not mean that power electronics only deals with the power levels. It can also be used to control the micro watts of power that can be used in different applications like medical instrumentations, then defense devices, etc. Even in our mobile systems.
Energy in the milliwatt range. Just like microelectronics deals with processing information, one can describe power electronics as a technique to process energy. The power semiconductors work as electronic switches, while additional passive components such as capacitors and inductors have to buffer the electrical energy. Around 40% of today's overall global energy consumption is electrical energy, and this proportion will continually increase in the next years. One of the key and enabling technologies on the way to a more electric world is power electronics, besides electrical energy storage technology. About 30% of the electrical energy can be saved by consistently using efficient power electronics with standard efficiency levels above 95% for the power conversion.
So the power conversion efficiency of those power electronic devices which are basically working as switches is very high, about 98%.
The European Union's ambitious climate goals for the reduction of energy consumption and CO2 emissions cannot be achieved with.
We cannot achieve the green energy targets until we are using the power electronic devices
without the extensive use of power electronics. After all, power electronics enables the efficient feeding in of wind and solar power to the grid, the stabilization of the power grids, while the share of fluctuating renewable energies is increasing, highly efficient variable speed motor drives. Energy efficiency.
One of the application of power electronics is DC and AC motor drives.
Efficient and low emission mobility.
Another application is in terms of mobility, that is electric vehicles or hybrid electric vehicles.
With electric and hybrid vehicles. Energy saving lighting technology. And the efficient energy recovery. Another application for energy efficient electrical drives is in automotive. This is not only related to the drivetrain, but also to the electrification of the auxiliary units, such as the cooling water pump, the air conditioning compressor, and the power steering. Fuel consumption can be reduced by about 10% with these measures. All of these aspects are challenges that young engineers from various industries work on. At automotive manufacturers and suppliers, at the development and production of electrical drive systems, and at the component suppliers for power semiconductors, passives, substrates, and heat sinks. Intersectoral and multidisciplinary teamwork working towards a common goal, assuring future energy with power electronics.
So friends, this is the video that gives us idea about what is the role of power electronics. So let us start with the formal introduction of this particular subject. Various definitions of power electronics has been given. This particular definition gives us the idea that it is a subject that deals with apparatus and equipment working on the principle of electronics but rated at power level rather than the signal level. So this is one of the definition, can be considered as true for big rated power devices like HVDC transmission line. Similarly, the power electronic can be considered as an interdisciplinary technology involving three basic fields: power, electronics, and control. So this power, electronics, and control that we are going to start in the next part of our introduction chapter. Thank you.